Hello, children. Welcome to our tuition classes. We are doing chapter 2 Pythagoras Theorem. All the theorems and the proofs what are there in this chapter. Okay, we are doing all the theorems and the proofs what are there in this chapter. So, the very first theorem is similarity and right angle triangles. Theorem in what? Similarity. Theorem on what? Similarity and right angle triangles. Theorem on similarity and right angle triangles. Theorem on सिमिलैरिटी का आइडिया आपको मालूम है और राइट एंगल ट्रायंगल के ऊपर ओके so what is that? See the question, children. Prove that. Suppose it comes in the form of a question. Prove that if an altitude is drawn from the vertex of a right angle to the hypotenuse, then the two triangles on either side of the hypotenuse are similar to the original triangle and to each other. Now, what is this? Can prove that if an altitude is drawn from the vertex of the right angle to the hypotenuse, then the two triangles on either side of the hypotenuse are similar to the original triangle and to each other. जब एक क्वेश्चन ऐसा आ गया पूरा स्टेटमेंट फॉर्म में उसको हम बोलते हैं राइडर. गॉट इट? इज राइडर फॉर्म में आया. तो अगर ऐसे फॉर्म में आएगा तो आपको 5 थिंग्स करना पड़ता है. आपको डायग्राम ड्रॉ करना पड़ेगा, आपको गिवन लिखना पड़ेगा, आपको प्रूव दैट लिखना पड़ेगा और उसका प्रूफ कंस्ट्रक्शन रहेगा तो कंस्ट्रक्शन बाद में प्रूफ. तो ना लेट्स ट्राई टू अंडरस्टैंड. ओके, तो आपको एक फिगर ड्रॉ करना पड़ेगा. तो आप थोड़ी बाय हार्ट करते हो लेकिन एक क्वेश्चन से समझना हमेशा याद रखो. इफ के बाद जो स्टेटमेंट आया है जो अंडरलाइन कर रहा हूं मैं. ओके, जो अंडरलाइन कर रहा हूं यू कैन सी व्हाट फॉलोज इट. ओके, आई एम अंडरलाइनिंग इट. Okay, like I underline here, just here. If what follows if an altitude is drawn from the vertex of a right angle to the hypotenuse, what I underline? What follows if before then? If के बाद, this is your given information. Altitude is drawn from the vertex of a right angle to the hypotenuse. Now remember, hypotenuse कौन सा triangle में रहता है? Right angle triangle में. So if the perpendicular is drawn from the vertex of a right angle भी right angle triangle में रहता है. मतलब एक right angle triangle draw करूंगा. Got it? So I draw one right angle triangle. You can see it, children. 1 minute. You can see this right angle triangle I'm going to draw, children. This right angle triangle, just have a look at this. I draw it, okay? Can you see? One angle 90. So this triangle is called a right angle triangle. Can you see? This triangle is a right angle triangle, okay? Why? Because it's one angle is 90 degrees. So it's called right angle triangle. Now, A, B, C. So which is the vertex of the right angle? B. Now the question is, if an altitude is drawn from the vertex of a right angle to the hypotenuse, see, B is the vertex of the right angle, AC is a hypotenuse. So perpendicular segment is drawn from the vertex of a right angle to the hypotenuse. Perpendicular segment is drawn from the vertex of a right angle to the hypotenuse. Can you see this? This is the perpendicular drawn from the vertex of a right angle to the hypotenuse, and BD is a perpendicular drawn. Got it? So this altitude is drawn from the vertex of a right angle to the hypotenuse. Means you can see here B is the vertex of the right angle. From this B, perpendicular is drawn to the hypotenuse. Side AC is a hypotenuse. Okay. Now, can you see two triangles are formed on either side of the perpendicular? These two triangles, the theorem says, these two triangles are similar to the original triangle and to each other. In short, तीनों triangle जो बना है figure में अभी totally तीन triangle है. तीनों triangle आपस में similar है. Okay. And now we are going to learn to prove it. So first thing I should write given. Given is what you can see here in triangle ABC. In triangle ABC, angle ABC equal 90. That means a right angle triangle, okay, which is the vertex of the right angle B. Segment BD is perpendicular to hypotenuse AC, children. Hypotenuse AC. Now, what did you prove? Then the two triangles on either side of the perpendicular, you can see these two triangles which are there on either side of the perpendicular are similar to the original triangle and to each other. So I better write the name of the original triangle. Children, when I write the name of the original triangle, I have my way. Children, I'll always try to write the vertex of the right angle as a middle letter. I'll write the vertex of the right angle as a middle letter of the three-letter name. It's a triangle. A triangle में vertex of the right angle is B. So B should be the middle letter. Means the बड़ा triangle का नाम ABC लिखो या CBA लिखो. तो B बीच में डालो. Okay. तो मैंने लिखा triangle ABC. Triangle ABC. Now, which is the other triangle? Now, these two triangles ka naam, you should always write it in one-to-one correspondence. I'm showing you the trick here. Just a trick, children. Trick, matlab just trick, okay? See, which is the vertex of the right angle of the smaller triangles? D is the vertex of the right angle of the smaller triangle. So D should be the middle letter in their name. So naturally, first two triangles, you can say first two letters here, AB. So what am I going to do? I'm going to do this, slip this D between them. And that becomes the name of the second triangle, triangle ADB. T को बीच में डाल दिया, B A और B का बीच में. Then children, the next one, what I do children, which is the vertex of the right angle? You said D. So I'm going to slip the, please have a look at it. I'm going to slip the vertex of the right angle. Can you see this D? This D, all can see. D is the vertex of the right angle for the small triangle. I'm going to slip this D between B and C. And that becomes the name of my second triangle. That will become the name of my second triangle. Okay. So what is a triangle? Please have a look at this. This is my triangle. You can see a triangle B P और C के बीच में D डाल रहे हो तो BDC. So I hope you can see the three triangles, children. Okay. And what I used to write the name of the three triangles, I hope everybody understood it. Okay. So in triangle ABC, angle ABC equal 90. Whenever I want to write the name of a right angle triangle, I'll always try to write the vertex of the right angle as a middle letter. Okay, no hard and fast rule, my method, I said. Okay, so in triangle ABC, what I see, perpendicular is drawn to the hypotenuse. BD is perpendicular to hypotenuse AC. Then these two triangles on either side of the perpendicular are similar to the original triangle and to each other. So how I write in short, I'll write the name of the big triangle first. Okay, so triangle ABC लिखो या CBA लिखो, मतलब B should be the middle letter. I लिख दिया मैंने. Abhi now look here. First two letters, how to write the name of the other two triangles now. So remember this trick, children. Okay, which is the vertex of the right angle? Which is the vertex of the right angle? For the smaller triangles, you can clearly see D is the vertex of the right angle for the smaller triangle. D is the vertex of the right angle for the smaller triangle. So what am I going to do? First two letter is AB. So what am I going to do? I'm going to slip in this D between A and B. D को बीच में डाल दूंगा. तो second triangle का नाम बन गया ADB. और third triangle का नाम कैसे याद रखूंगा? B और C, third and second and third letter B और C है. उनके बीच में D डाल दूंगा. So BDC. So all the three triangles name I have written. Okay? And so simple, children. The proof is. Now look at the big triangle ABC and look at this triangle ADB. Look at the big triangle and also look at the small triangle ADB, children. Can you see this ADB, children? I'll just show it to you. So simple it is. This is my triangle ADB. You can see this triangle ADB. Okay. This is my triangle ADB. Or you can see this triangle ADB, children. Little different. I'm trying to show it here. Can you see this triangle ADB? And can you see the big original triangle? Okay. Now, ध्यान से देखो. The big triangle. Please have a look at the big triangle. Original triangle. The original triangle and this triangle ADB. Original triangle ABC and triangle ADB. Original triangle ABC and triangle ADB को देखो. In triangle ABC and triangle ADB. Don't you agree? Angle ABC is congruent angle ADB. Each is 90. Then angle A, congruent angle A, common angle. So don't you realize two angles of the big triangle are congruent to two angles of the small triangle. So ABC is similar to ADB by A test. So let us try to write the proof for it. First, I'm going to take the big triangle. Please have a look here. In triangle ABC, in triangle ABC and triangle ADB. You have written the names in proper one-to-one correspondence. From here itself, I write in triangle ABC and ADB. Well, angle ABC is congruent to angle ADB. You can see here, children, each is 90 degree. Each is 90 degree. Each is 90 degree. Now you can see angle A is congruent to angle A because it's a common angle for both the triangles. I just write single letter name, okay? So now look here, children. Can I say that for triangle ABC is similar to triangle ADB by double A test, children, by AA test. So I got one statement, okay? ABC is similar to ADB. Now what am I going to do? I'm going to take my triangle ABC and compare it with the small triangle BDC. I'm going to take this triangle ABC and compare similar, try to prove it similar with the small triangle. You can see here this small triangle, okay? The small triangle is BDC. You can see from here in the diagram, BDC, okay? So I'm going to now look at the big triangle and please have a look at the small triangle, okay? Going to look at the big triangle ABC and BDC in triangle ABC. Can you see this triangle ABC, children? And triangle BDC. Please look at the figure. ABC and BDC. Again, angle ABC is congruent to angle BDC, children. Angle ABC is congruent to angle BDC. What are the reason, children? Each is 90 degree. Each is 90 degree, children. Then look at this angle C, children. This angle C is a common angle for both the triangles. Angle C, common angle C. Don't you agree? Common angle for both the triangles. Common angle, okay? So naturally, what will happen, children? That for triangle ABC. Can you see this triangle ABC? Similar triangle BDC by statement number 2, children, by A test. Now, please look at statement number 1 and 2. ABC is similar to ADB. Same ABC is similar to BDC. Triangle ABC is similar to triangle ADB. Same triangle ABC is similar to triangle BDC. Same ABC it is. So can I say all the three triangles are similar? Therefore, triangle ABC, similar triangle ADB, similar triangle BDC from 1 and 2. From 1 and 2. Such a easy proof of this theorem, children. Sometimes it is asked, okay? So now onwards, I taught you the proof. Now onwards, whenever you see from the in a right angle triangle, from the vertex of the right angle a perpendicular altitude is drawn to the hypotenuse. तो तुरंत आपके दिमाग में आने चाहिए तीनों ट्रायंगल सिमिलर है तीनों ट्रायंगल सिमिलर है by theorem on similarity and right angle triangles by theorem on similarity and right angle triangles theorem on similarity and right angle triangles. I hope people have got me here, children. Very simple. Sure, children. We go to the next theorem now. We go to the next theorem. We go to the next theorem. The next theorem, children, theorem number 2, theorem of geometric mean. Actually, it's a corollary of the theorem on similarity and right angle triangles. It's a corollary of it. It's a property derived from it. Just have a look at this statement. In a right angle triangle, the length of the perpendicular segment drawn on the hypotenuse from the opposite vertex is the geometric mean of the segments into which the hypotenuse is divided. In a right angle triangle, matlab, if you see any right angle triangles, okay, like this is a right angle triangle, this is a right angle triangle, okay? Now, in a right angle triangle, you see a perpendicular segment is drawn to on the hypotenuse, okay, which is hypotenuse of this AC. A perpendicular segment is drawn on the hypotenuse, okay. Now, what does it mean, children? A perpendicular segment is drawn on the hypotenuse from its opposite vertex. So you can see here, children, a perpendicular segment is drawn on the hypotenuse from its opposite vertex. You can see here, BD is a perpendicular segment drawn on the hypotenuse from its opposite vertex. Whenever you see this condition, it should come to your mind This length of this perpendicular segment is a geometric mean of the segments into which the hypotenuse is divided. Got it? अभी ये geometric mean का मतलब क्या? So I'll tell you, algebra में आपने सीखा है x is geometric mean of y and z. मतलब क्या है? x अकेला है, y and z साथ में, मतलब x square equal y into z. A is geometric mean of B and C. What does it mean? A square equal B into C. तो इधर क्या बोलता है? Perpendicular segment drawn to the hypotenuse from the opposite vertex, which is that BD, is geometric mean of the divided of the segments into which the hypotenuse is divided. Hypotenuse is divided into segment AD and CD. AD and CD. So naturally, BD is a geometric mean of the segments into which the hypotenuse is divided. BD is a geometric mean of AD and CD. मतलब formula क्या आएगा? BD square. जैसे x is geometric mean of y and z, so x square equal y into z. A geometric mean of B and C, A square equal B into C. So BD is geometric mean of BD and CD. So BD square equal AD into CD. Are you getting me here? So now onward, whenever you see like this, from the vertex of a right angle, perpendicular is drawn on the hypotenuse. Then length of that perpendicular is the geometric mean of the segments into which the hypotenuse is divided. Are you getting me? This should come to your mind. Now let's try to write a proof for it, children. Very easy proof, okay? So just have a look here. Now, why it's a corollary of property of corollary of similarity theorem on similarity and the right angle triangles. I'll tell you, children. Just have a look here. Got it? Suppose I want BD square in this. What is given? Inner right angle triangle. That means I'll first write given inner right angle triangle. मतलब right angle triangle पहले से ही मतलब in triangle ABC. Angle ABC is 90. And you see a perpendicular segment is drawn from the vertex to the hypotenuse from its opposite vertex. BD is perpendicular to hypotenuse AC. Then, okay, this formula, the perpendicular length of the perpendicular segment is a geometric mean of the segments in which a hypotenuse is divided. मतलब BD square equal AD into CD. Okay, BD square equal AD into CD. तभी इसका proof लिखना है इसका proof. Okay, BD square equal AD into CD. Now listen, क्या आएगा last line? BD square equal AD into CD. तो याद रखो बेटे, BD square equal AD into CD कैसा आ सकता है? Naturally, second last line कुछ ratios बना रहेगा ऐसा. वो ratios को cross multiply करके ही आंसर आता है. तो ratios का equal कैसे दिखाते हैं? तो रेशियोज के इक्वल दिखाने के लिए सिंपल दो ट्रायंगल को सिमिलर प्रूव करना है. गॉट इट? तो अब ये ट्रायंगल्स कैसे ढूंढेंगे? तो वो भी बहुत सिंपल है. अगर स्क्वायर रहेगा ना, स्क्वायर वेरी इजी. एक ट्रिक याद रखो, इसमें बीडी स्क्वायर है, मतलब बीडी दो ट्रायंगल का साइड रहनी चाहिए. बीडी स्क्वायर है, इसके लिए बीडी शुड बी द साइड ऑफ टू डिफरेंट ट्रायंगल्स. इट शुड बी द साइड ऑफ टू डिफरेंट ट्रायंगल्स. ऐसे ट्रायंगल्स ढूंढो इसका बीडी स्क्वायर है. इसके लिए बीडी शुड बी द साइड ऑफ बोथ द ट्रायंगल्स. ओके, so can you search such a triangle here? You can see here BD is a side of triangle ADB. Can you see here? And BD is also a side of triangle BDC. Triangle ADB. BD is a side of triangle ADB and BD is a side of triangle BDC. BD is a side of triangle ADB. BD is a side of triangle BDC. दोनों ट्रायंगल को सिमिलर प्रूव करना है. Got it? ये दोनों ट्रायंगल को कौन सिमिलर प्रूव करूंगा? I can use similarity theorem on similarity and the right angle triangles. Like, please have a look here. How I use a theorem? Can you see the big triangle ABC? In triangle ABC, got it? What I see the condition, children? I see the condition. Angle ABC equal 90 degrees. ये condition दिख रहा है. और एक condition दिख रहा है, क्या है? BD perpendicular hypotenuse AC. ये दोनों कंडीशन दिख रहा है आपको. जब ये दोनों कंडीशन दिख रहा है तो आपको इन अ राइट एंगल ट्रायंगल perpendicular is drawn to the hypotenuse, then remember all the three triangles formed in the figure are similar. Triangle ABC, the vertex of them right angle has a middle letter triangle ABC similar triangle पहला दो लेटर ए बी है तो उनके बीच में which is the vertex of the right angle in a small triangle D तो ADB और लास्ट दो लेटर BC उनके बीच में D ट्रायंगल BDC गॉट इट बाय इसको स्टेट नंबर 1 बोलता हूं बाय similarity by theorem on similarity and the and right angle similarity and right angle triangle similarity and right angled triangles okay now you can see here children आपको जो आंसर मिलता है बीडी इसका बीडी कौन सा जो ट्रायंगल का साइड है एडीबी और बीडीसी एडीबी और बीडीसी इधर सिमिलर हो गया सो ट्रायंगल एडीबी रीराइट triangle ADB to get your answer you're going to rewrite you want this as an answer okay you want this as an answer so you're going to rewrite triangle ADB similar triangle BDC can I say from one I said in one, all three triangles are similar, but I would like to get this because I want BD. BD is the side of these two triangles. Now, once the triangles are similar, the corresponding sides are in proportion. Pahla do letter AD, pahla do letter BD. Second and third letter BD upon CD equal AB upon BC. लेकिन नहीं मांगता हो because this is giving me BD square. Can you see here? Corresponding sides of similar triangles. 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 And then you get your answer. BD square equal AD into DC. Okay. A very simple one, children. We go to the next important theorem now. Now, this is theorem number 3, children. Now, this theorem number 3, what it says, its name is Theorem of Pythagoras. The name of this theorem is Theorem of Pythagoras. And then what it says, in a right angle triangle, it is whenever you see a right angle triangle, in a right angle, only in a right angle triangle, okay? The square of the hypotenuse is equal to sum of the squares of the remaining two sides. Like, for example, just have a look here. So this is a right angle triangle. This is a right angle triangle, okay? In a right angle triangle. That means, see here, you see a right angle triangle, suppose triangle ABC. So this is a right angle triangle, in a right angle. Square of the hypotenuse. Which side is called a hypotenuse? The side opposite to 90 is called a hypotenuse. So इसको hypotenuse बोलते हैं, side opposite to 90 को hypotenuse बोलते हैं. The square of the hypotenuse. So इधर side opposite to 90 क्या है? AC है. मतलब AC hypotenuse है. Square of the hypotenuse. मतलब AC square is equal to sum of the squares of the remaining two sides. Sum मतलब addition. Addition of the squares of the remaining two sides. मतलब AB square plus BC square. Okay, this is what the theorem is. Square of the hypotenuse equals sum of the squares of the remaining two sides. Got it? अभी square of the hypotenuse is equal to sum of the squares of the remaining two sides. मतलब you see a right angle triangle. Anyhow, the right angle triangle can be. Suppose this is a right angle triangle, children. Here, the right angle triangle, you can see here. Angle Y is 90. So which is the hypotenuse? XZ. So what will be the Pythagoras theorem here? XZ square equal XY square, sum of the squares of the remaining two sides. XY square plus YZ square. Are you getting me here? The right angle triangle can be anyhow. Please have a look here. Right angle triangle is like this, children. This is my triangle LMN. M is 90. So what will be the Pythagoras theorem here? Ln square equal Lm square plus Mn square. Okay. You understand? Ln square equal Lm square plus Mn square. What is the use of this right angle Pythagoras theorem, children? जब भी कोई triangle का दो साइड दिया है, जैसा ये साइड और ये साइड दिया है, दो साइड दिया है, तीसरा साइड निकाल सकते हैं by Pythagoras theorem. जैसा AC square equal AB square plus BC square. So 5 square equal 4 square plus BC square. So 25 equals 16 plus BC square. 25 minus 16 equal BC square. So BC square equal कितना आएगा बेटा? इधर 25 इधर लिखता हूँ 25 equal 16 plus BC square. So what will happen? 25 minus 16 is equal to BC square. So BC square 9 is equal to BC square. तो BC equal 3. तो जब भी दो साइड्स मालूम रहेगा राइट एंगल ट्राइंगल का तो तीसरा साइड निकाल सकते हैं, लेकिन ऐसा ऐसे ही सॉल्व नहीं करना, आपको पहला ट्राइंगल का नाम लिखना पड़ता है इन ट्राइंगल एबीसी, बाद में उसमें 90 डिग्री एंगल दिखाना पड़ता है, एंगल एबीसी इक्वल 90 डिग्री, उसके बाद आपके फॉर्मूला लिख सकते हैं AC स्क्वायर इक्वल AB स्क्वायर प्लस BC स्क्वायर और इधर बाय पाइथागोरस थ्योरम और वैल्यूज डाल सकते हो। जैसे इधर प्लीज हैव अ लुक हियर, अगर ये किया के 12 है ओके और ये 5 है और एग्जैक्ट पूछा है, तो अगेन चिल्ड्रन बाय टू साइड्स ऑफ अ राइट एंगल ट्रायंगल, दो साइड्स राइट एंगल ट्रायंगल का मालूम है, तो तीसरा साइड प्लीज हैव अ लुक, हम लोग निकाल सकते हैं बाय यूजिंग पाइथागोरस थ्योरम। तो कैसे यूज करते हैं? पहला ट्रायंगल का नाम इन ट्रायंगल एक्स वाई जेड, ओके, बाद में 90 डिग्री एंगल, क्या 90 वाई 90 है मतलब एक्स वाई जेड इक्वल 90 डिग्री एंगल, तो क्या होता है दिस इज गिवन, सो व्हाट विल बी पाइथागोरस थ्योरम? देखो xz स्क्वायर xz स्क्वायर, ओके दिख रहा है xz स्क्वायर इक्वल हाइपोटेन्यूज xz है, xz स्क्वायर इक्वल xy स्क्वायर, इधर नाम से भी देख सकते हैं xz हाइपोटेन्यूज है, y को छोड़ के बाकी दो लेटर xz हाइपोटेन्यूज है, इज इक्वल टू xy स्क्वायर प्लस yz स्क्वायर बाय पाइथागोरस थ्योरम, ओके। डाल दो वैल्यूज, एग्जैक्ट नहीं मालूम लेकिन बाकी दोनों मालूम है, 12 स्क्वायर प्लस 5 स्क्वायर, एग्जैक्ट स्क्वायर इक्वल 144 प्लस 25, एग्जैक्ट स्क्वायर इक्वल 169, एग्जैक्ट स्क्वायर इक्वल 160, एग्जैक्ट इक्वल रूट ऑफ 169, कितना आएगा बेटा? एग्जैक्ट इक्वल 13 यूनिट्स। तो याद रखो पाइथागोरस थ्योरम का काम क्या है बेटा? जब भी दो साइड्स मालूम है राइट एंगल ट्रायंगल का, ओके, तीसरा साइड निकाल सकते हैं पाइथागोरस थ्योरम से। अभी देखो बेटा ये एग्जाम में किस तरह से आता है, ये क्वेश्चन एग्जाम में पाइथागोरस थ्योरम का प्रूफ किस तरह से पूछा जाता है, ओके। In an exam, it will come like this. आपके एग्जाम में इस तरह से आएगा, prove that in a right angle triangle, square of the hypotenuse is equal to sum of the squares of the remaining two sides. Prove that in a right angle triangle. मतलब, got it? You have to, it will just come in this form. इसको क्या बोलते हैं? राइडर फॉर्म। तो आपको पहला डायग्राम ड्रॉ करना पड़ेगा। तो इनर राइट एंगल ट्रायंगल, क्लियर कट इनर राइट एंगल ट्रायंगल, तो आपको राइट एंगल ट्रायंगल ड्रॉ करना पड़ेगा, ओके। आप एक राइट एंगल ट्रायंगल ड्रॉ करेंगे इधर, ओके, एक राइट एंगल ट्रायंगल ड्रॉ करेंगे, ओके, दिस इज अ राइट एंगल ट्रायंगल, inner right angle triangle, okay, then just a right angle triangle you'll draw in, and you'll write now, name it as ABC. Suppose I name this as A, B, B is 90, okay, inner right angle triangle, so in triangle ABC, this is my given, okay, जो ड्रॉ करता है वही उसका पिक्चर टॉप, उसको बोलते हैं गिवन। जो ड्रॉ किया हमने, क्या ड्रॉ किया? राइट एंगल ट्रायंगल, तो हम लोग उसको गिवन में लिखेंगे ऐसा, इन ट्रायंगल ABC, एंगल ABC इक्वल 90 डिग्री, मतलब ये राइट एंगल ट्रायंगल हो गया। आपको क्या प्रूव करना है? आपको प्रूव करना है स्क्वायर ऑफ द हाइपोटेन्यूज, AC इज हाइपोटेन्यूज मतलब AC स्क्वायर इक्वल sum मतलब addition of the squares of the remaining two sides, AB and BC are the remaining two sides, addition of the squares of the remaining two sides मतलब AB square plus BC square, ये remaining two sides AB और BC, उनका squares AB square और BC, sum of the squares of the remaining two sides मतलब AB square plus BC square। आपको ये प्रूव करना, बस इतना दिया। अभी क्या करें बेटा? तो प्लीज have a look here. Regarding this right angle triangle, there is one theorem. Okay, what is that? Similarity theorem on similarity and the right angle triangles. Got it? Similarity and but for that a perpendicular segment is needed. So naturally, this becomes a construction, children. This becomes a construction. What I do, From the vertex of the right angle, a perpendicular segment I draw BD perpendicular to AC. This construction I do, got it? So construction, we'll write construction, children. Now, what is the construction we are writing? Construction, draw segment BD, perpendicular hypotenuse AC, And where is this D lying on AC? So A dash, D dash, C. Now look here, very simple, children. I want people to pay attention here. What I realize is, children, the moment you see in a right angle triangle, from the vertex of the right angle perpendicular is drawn to the hypotenuse, totally हमारे पास तीन ट्रायंगल है, दो छोटे और एक बड़ा. तीनों ट्रायंगल आपस में सिमिलर है, मुझे मालूम है. Correct. So I'm going to write that first, like in triangle ABC. Lekin why? Why have to write? You'll understand very soon. In triangle. क्यों लिखना है ये? In triangle ABC. देखो एंगल ABC इक्वल 90 डिग्री, ये तो आपको गिवन है. गॉट इट. और बाद में आपने जो कंस्ट्रक्शन किया, सेगमेंट BD परपेंडिकुलर हाइपोटेन्यूज AC, ये तो आपने कंस्ट्रक्ट किया है बाय कंस्ट्रक्शन. व्हेनेवर यू सी ये दो कंडीशन दिखा आपको, तो आप तीनों ट्रायंगल पिक्चर में जो है सिमिलर है. तो आप कैसे लिखते हैं? therefore ट्रायंगल ABC, बिग ट्रायंगल वर्टेक्स B इज द मिडल लेटर, ट्रायंगल ABC सिमिलर. पहला दो लेटर AB है, उनके बीच में वर्टेक्स ऑफ द राइट एंगल इज D फॉर द स्मॉल ट्रायंगल. तो AB के बीच में D आएगा. दूसरा ट्रायंगल का नाम ADB. गॉट इट. फिर तीसरा ट्रायंगल का नाम, सेकेंड एंड थर्ड लेटर BC है, वर्टेक्स ऑफ द राइट एंगल इज D, तो B और C के बीच में D आएगा, ट्रायंगल BDC. ओके, आई जस्ट कॉल दिस एज वन by theorem on similarity and the right angle triangle, similarity and the right angle triangle, similarity and the right angled triangles. Right angled triangles. Are you getting me? A similarity and the right angled triangles. Now let's see here, children, how to remember this. Always remember, children, how will I remember this proof? Okay, AC square equal AB square plus BC square. मुझे AB square मांगता है, मुझे AB square पहला चाहिए, राइट हैंड साइड का AB square. बाद में मुझे BC square चाहिए, बाद में मैं AB square और BC square का ऐड करूंगा और आंसर लाऊंगा. तो मुझे AB square चाहिए. AB square कैसे मिलेगा बेटा? तो नेचुरली बाय सिमिलैरिटी मिल सकता है. अगर रेशियो में ए बी ऊपर है ए बी नीचे है, तो नेचुरली चिल्ड्रन ए बी स्क्वायर मिल सकता है. लेकिन ये रेशियो कैसे लाएंगे? बाय प्रूविंग ट्रायंगल सिमिलर. तो ये ए बी स्क्वायर मैंने बताया था एक ट्रिक जैसा. ए बी स्क्वायर चाहिए. तो ए बी स्क्वायर, ए बी कौन सा दो राइट एंगल ट्रायंगल का साइड है? देखो इसमें ए बी है, इसमें ए बी है, बीडीसी में नहीं, लेकिन इसमें है ए बी और इसमें ए बी है. ये दोनों ट्रायंगल सिमिलर पहला लूंगा. ट्रायंगल ABC, similar triangle ADB. I just call it from one, okay? Then I'll raise similar AB upon AB mangta hai, AB upon AD. Can you see? AB upon AD equal, okay? AC upon AB, corresponding sides. AC upon AB. BC upon DB name AC upon AB, okay? Reason, corresponding sides of similar triangles. Corresponding sides of similar triangle. Corresponding sides of similar triangles. देखो अभी AB क्रॉस मल्टीप्लाई करो, AB स्क्वायर इक्वल क्या आएगा? AD into AC. I call this as 2. I call this as 2. I call this as 1, okay? This is 1. This is statement number 2, okay? Now in the same way, I want BC square. BC कौन सा दो triangle का side है? BC इधर है, इसमें नहीं. हाँ, इसमें है BC. Can you see here? So I'll take this triangle ABC once again to get BC square. Triangle ABC, similar triangle BDC. Reason from one, okay? Again, once the triangles are similar, corresponding sides are in proportion. आपको BC मांगता है, तो देखो AB upon BD. BC वाला, BC वाला देखो, BC अपॉन BC का साथ क्या है, DC, BC upon DC is equal to AC upon BC. Again, children, you can see here corresponding sides of similar triangles, corresponding sides of similar triangles, corresponding sides of similar triangles. You can write full form, children, by the way, right symbol, cross multiply, BC square equal, can you see a BC square equal DC into AC? Can I say this is my stator number 3, okay? This was my stator number 2. This is therefore BC square equal. Now what I want in my answer AB square plus BC square. क्या मांगता है मुझे, AB square और BC square मांगता है. तो ये क्या करूंगा मैं, प्लीज have a look here. I want AB square plus BC square. I want AB square plus BC square. So adding 2 and 3. So क्या आएगा, AB square plus BC square is equal, लेफ्ट हैंड साइड ऐड हो गया तो राइट हैंड साइड भी ऐड हो जाएगा, AD into AC plus DC into AC. Reason is adding 2 and 3, adding 2 and 3. Lekin now listen here, you're not got an answer, but very soon you'll get an answer. AB square plus BC square. What is common in this two? AC is common. So AD plus DC. Got it? Now AD and DC, when you add, what do you get, children? AB square plus BC square is equal to AC into AC. What is this? A dash D dash C. AD and DC, when you add, you get AC. Now, what is this? AC square. Therefore, AB square plus BC square equal AC square. That is what you write AC square first. Okay, AC square equal AB square plus BC square. Got it? We got the answer, children. Very simple proof. Okay. I hope people have understood me here. We go to the next here. This is important. This can be asked in your exam. Converse of Pythagoras theorem, children. And next theorem, theorem number. Please have a look here. Whatever. I'm not writing a theorem number now. Converse of the Pythagoras theorem. Like in a triangle, if a square one side is equal to sum of the squares of the remaining two sides, then the angle opposite to the first side is a right angle and the triangle is a right angle triangle. शॉर्ट में इसका मतलब क्या है, अगर आपके पास एक ट्रायंगल है और अगर किसने भी, प्लीज हैव अ लुक हियर, किसी ने भी पूछ लिया, अरे भाई ये ट्रायंगल राइट एंगल ट्रायंगल है क्या, this triangle is a right, it's not marked, okay, it's not marked, nothing, no 90 degrees marked. But is this triangle a right angle triangle? Is this triangle a right angle triangle? ये ट्रायंगल राइट एंगल ट्रायंगल है क्या, नहीं, पूछ लिया. Then remember, अगर ये तीनों ट्रायंगल का तीनों साइड दिया हुआ है, आपको तीनों साइड दिया हुआ है, जैसे 10 है, ये 8 है, ये 6 है, लेकिन ये 90 नहीं दिया है. करेक्ट? तो ये राइट एंगल ट्रायंगल है क्या, नहीं पता लगाना. तो याद रखो, स्क्वायर ऑफ द ग्रेटेस्ट साइड निकालो. विच इज द ग्रेटेस्ट साइड हियर? 10. तीनों में से सबसे बड़ा नंबर 10 है. तो AC स्क्वायर इक्वल 10 स्क्वायर कितना हो गया? 100. अब बाकी दोनों छोटा साइड को ऐड करो. AB स्क्वायर प्लस BC स्क्वायर ऐड करो, कितना होगा? बाकी दोनों छोटा हो गया. Square of the bigger side निकाला, the sum of the squares of the remaining two sides. क्या आएगा? 8 square plus 6 square. ये 64 होता है, ये 36, and how much you get? 100. So again, don't you realize square of one side is equal to sum of the squares of the other two sides? है ना कंडीशन. Therefore, the angle opposite to the first side, AC का opposite कौन सा है? B है ना. So that angle is 90 degree. You can say by converse of Pythagoras theorem. Converse of Pythagoras theorem. Okay, Pythagoras theorem. And hence I can also say triangle ABC is a right angle triangle. Triangle ABC is a right angle triangle. So remember, what is corners of Pythagoras theorem? The square of any one side, triangle मालूम है, triangle है, लेकिन ये ट्रायंगल राइट एंगल ट्रायंगल है कि नहीं, दिया नहीं है। तो कैसा पता चलेगा? बाय अ थ्योरम, ओके। A square of a greater side, if it is equal to sum of the squares of the two smaller sides, then the angle opposite the greater side is 90, and the triangle is a right angle triangle. Got it, children? I hope you understood this theorem. Now, in your exam, they can ask you in the form of a question, okay? They can ask you in the form of a question, like prove that in a triangle, if the square of one side is equal to sum of the squares of the other two sides, then the triangle is a right angle triangle. Then the angle opposite at first side is right angle. They'll ask you to prove this, okay? Like they'll ask you in the form of a question, okay? I'll not write it like a theorem of corners or Pythagoras theorem. I better change it to question like this. Prove that inner right angle triangle. Prove that inner right angle triangle is square of one side is equal to sum of the squares of the remaining two sides. Then the angle opposite to the first side is 90-degree right angle, and the triangle is a right angle triangle. You have to prove this. So what is given is inner triangle, okay? Now naturally, inner triangle. How am I going to take the triangle here? Little of common sense, children. I'm going to take this triangle like this, okay? I'm going to draw this triangle in this way, children. I'm going to draw it, okay? I'm going to draw it like a right angle triangle. Only thing, I'll not mark 90-degree angle. I'll not mark 90-degree angle because ultimately I want to prove it's a right angle triangle. So I should try to show somewhat, okay? It should look like a right angle triangle. But please here, it's not, I don't mark 90-degree angle. So what is given in this triangle is in this given in this triangle ABC, okay, square of one side, square of whatever follows if is given, square of one side is equal to sum of the squares of the remaining two sides. Okay, this is given, okay, and whatever follows, then you have to prove that, okay. So what is given? Square of one side is equal to sum of the squares of the remaining two sides. Like AC square is equal to AB square plus BC square. And what do you want to prove that? You want to prove that the angle opposite to that side is 90-degree. Which is the angle opposite to AC, children? B. Angle ABC equal 90-degree. You want to prove this, okay, children? So what we do, okay, this is what is given. I want to prove it, okay? So please have a look here. What I do, actually, I'll put it like this. This given, I'll write it below, okay? This given, I will write it below, children. Sorry, it's to the side, I'll not write, but given, I'll write it below, okay? Like what is given to me, okay? In this triangle given, okay? In this triangle ABC, in triangle ABC, what is given? Square of one side. Let's take AC square equal AB square plus BC square. Square of one side is equal to sum of the squares of other two sides. And what you want to prove that, children? You want to prove that the angle opposite at the first side, that is angle opposite to AC, ABC is 90-degree. Okay, I want to prove it's a right angle. Okay, now why did I rub it off from here? I'll tell you, because there is a construction, children. See what I do, I draw one triangle in such a way, I draw a new triangle. See how to show this 90. There's no way, only this way. Please here, what I do, I draw one triangle in such a way that it looks like, please have a look here. It is such that I draw a triangle PQR in such a way that it's this side PQ is actually equal to AB, and this QR I take it equal to BC. But the third side, of course, this angle between these two sides is 90. So I can construct this triangle, okay? I construct a triangle PQR. Children, I should have shown it as a dotted line, but can't show it as dotted line. This should be dotted line. This should be, the figure should be in dotted line. This figure should be in dotted line. This figure should be in dotted line. The figure should be in dotted line. Should be in dotted lines. Okay, you cannot show the way I marked it. Okay, it should be in dotted lines. Okay, I draw triangle PQR such that this PQ equal AB, QR equal BC, and but angle PQR is 90. See, I want to prove angle B is 90. So I get an idea. अगर ये दोनों triangle को किसी भी तरह congruent prove करूंगा, then I can say B congruent to QCACD. But how to show this triangle is congruent? AB is equal to PQ, BC is equal to QR. ये AB साइड PQ का इक्वल है, BC साइड QR का इक्वल नहीं है, BC साइड QR का इक्वल है, लेकिन एक और एक इंफॉर्मेशन चाहिए. See, this triangle I'm able to construct because this length is equal to this length, QR equal BC, but PQ is 90. So I'm able to construct this triangle. Got it? I'm able to construct this triangle with Q 90 degree. Got it? Now look here. Only thing PQ equal AB, QR equal BC, and angle Q equal 90 degree. But now I want to prove both these triangles are congruent. So always, like I tell you children, always children, your given information is a hint. What is given to you? Just have a look here. What is given to you? AC square equal AB square plus BC square is statement number 1 given. Am I right? But just have a look here. What did you construct, children? AB equal, AB का equal क्या है? PQ. BC का equal क्या है बेटा? You constructed equal to QR. You constructed it, okay? Statement number 2, statement number 3 given. By construction. I'll say by construction. By construction. So can I say, children, by construction, okay? Just have a look here. Now, can I say here, therefore, AC square equal, in place of AB square, can I put PQ square? Substitute. In place of BC, BC is what? QR square. Can I put like this? Can I say from 1, 2, and 3? From 1, 2, and 3. Okay, but I call this as 4. I call this as 4. I got this, children. AC square equal AB square plus BC square is given, but AB equal PQ. I constructed PQ equal AB, and QR equal BC. Therefore, please have a look here. AC square equal PQ square plus QR square. But don't you agree? In this triangle PQR, just have a look at this triangle PQR. You have taken a condition, angle PQR equal 90 degrees given. Sure, given PQR equal 90 degrees given. Therefore, what is Pythagoras theorem? PR square equal PQ square plus QR square. By Pythagoras theorem. Statement number 5. By Pythagoras theorem. Just now compare Pythagoras theorem. Now just compare your statement number 4 with 5. What is this? AC square equal PQ square plus QR square. Here PR square equal PQ square plus QR square. So what I do, therefore, you realize AC square equal PR square from 4 and 5. From 4 and 5. Now don't you agree square root? Therefore, AC equal PR. Can I call it shade number 6? Now look at the two triangles. Your AC equal PR you got. Easily I can prove both the triangles congruent in triangle ABC and triangle PQR. Can you see the two triangles, children? Can I say segment AB congruent segment PQ by construction, children? Segment BC congruent segment QR by construction. This two दोनों का reason by construction. Okay, but please have a look here. But segment AC is congruent to segment PR. Can I say from 6? Can I say from 6? And now, can I say therefore triangle ABC is congruent to triangle PQR by SSS test of congruence. Now, since both the triangles are congruent, they fit over each other. Angle B का साथ क्या fit होगा? Q. So angle ABC, congruent angle PQR. Can I say statement number 7? CACT, corresponding angles of congruent triangles. But what is PQR equal part? PQR equal 90 degrees by construction. By construction. Therefore, can I say, therefore, angle ABC equal 90 degrees. Sure, children, we got angle ABC equal 90. So triangle ABC is a right angle triangle. So triangle ABC is a right angle triangle. Okay. So this is a proof of your converse of Pythagoras theorem. Converse of Pythagoras theorem. We go to the next children. Now, the measures of the angles of the triangle are 30 degrees, 60 degree, and 90 degree. Then, length of the side opposite to 30-degree angle is half the hypotenuse, and length of the side opposite to 60-degree angle is root 3 upon 2 times the hypotenuse. Basically, these are two formulas, and they are given a name, 30, 60, 90 theorem. So remember this 30, 60, 90 theorem, children. The measures of the angles of a triangle are 30 degrees, 60 degree, and 90 degree. Then, length of the side opposite to 30-degree angle is half the hypotenuse, and length of the side opposite to 60-degree angle is root 3 upon 2 times the hypotenuse. What do you mean by it? I'll just show it to you. मतलब क्या है इसका? ओके, देखो, अगर एक राइट एंगल ट्रायंगल है जिसका एक एंगल 30 डिग्री है, one angle is 30 degree. Okay, one angle is 30 degree, one angle is 60 degree. Okay, another is 90. That means the measure of the angles of the triangle are 30 degrees, 60 degree, 90 degree. This combination. That remember the side opposite to 30. Which is the side opposite to 30, children? 30 degrees here. You can see angle C is 30. So triangle ABC, mein angle C is 30. So बाकी दो letter AB है ना? Side opposite to 30 है. AB is the side opposite to 30. ये AB formula half AC, half the hypotenuse बोल सकते हैं. And side opposite to 60. देखो angle A is 60 here. So which is the side opposite to it? BC. This BC is root 3 upon 2 times the hypotenuse AC. So these two formulas basically is called 30, 60, 90 theorem. Are you getting me, children? Now, in your exam, they can always ask you in a form of a prove that. Are you getting me here? That is what I'm interested in showing it to you here. Okay? They can always ask you in the form of prove that. Okay? Like they can always ask you, prove that if the measures of the angles of a triangle are 30 degrees, 60 degree, 90 degree, then length of the side opposite to 30-degree angle is half the hypotenuse. Length of the side opposite to 60-degree angle is root 3 upon 2 times the hypotenuse. Either one of them they may ask you to prove. Got it? So what I do, children, suppose the first one, let us try to prove both, okay? The measures of the angles of a triangle are 30 degree, 60 degree, 90 degree. I told you, children, whatever follows if is given to you. When measure of the angles of a triangle are 30 degree, 60 degree, 90 degree is given. Okay, that means I should draw a picture of it, okay? I should draw a picture of it. Like here, children, you can see here. Let me take this as this picture, okay? 1 minute. I'll take it here little. I'll adjust my spacing also so that you can understand better. Okay, see here, children. I draw this right angle triangle, okay? This. Now try to understand me here. Okay, what I do, this angle B is 90. I'll take angle C is 60. And I'll take angle A as 30. I 30 as my top angle. Okay, I'll take it in my figure. I'll take 30 as my top angle. Okay. .30 degree as my top angle. So please keep in your mind, children, This angle is 30. This angle is 30. This angle I have taken it as 30. Okay. You can see here. Now, this is what is given. What is given, children? In triangle ABC, given is here. I'll write given here. In triangle ABC, angle A, in triangle ABC, angle B equal 90 degree, angle C equal 60 degree, angle A equal 30 degree. And आपको prove करना है, prove that side opposite to 30, which is the side opposite to 30, BC is half AC. BC is half AC. And you have to prove side opposite to 60, AB is root 3 upon 2, root 3 upon 2 AC. Okay? You want to prove this. So remember, whatever follows if is given. The measure of the angles of a triangle are 30 degrees, 60 degrees, 90. Means I draw a figure accordingly. I draw a triangle where one angle is 90, one angle is 60, one angle is 30. Now what I want to prove that 10 के बाद जो है prove करना है. That means आपको क्या prove करना है? First part, length of the side opposite to 30 degrees half the hypotenuse. मतलब BC is half AC. And length of the side opposite to 60 degree angle, which is that AB. AB is root 3 upon 2 BC, AC. Okay? Now, how can it go about? So, please have a look at it. जब भी प्लीज आई जस्ट प्रूव बाद में देखते हैं, जरा इधर देखो. ओके, अगर एक कोई भी सेगमेंट पी क्यू है और उसका मिड पॉइंट एम है, तो हम क्या लिख सकते हैं बेटा? पी एम इक्वल हाफ पी क्यू लिख सकते हैं, या क्यू एम इक्वल हाफ पी क्यू लिख सकते हैं. आर यू गेटिंग मी चिल्ड्रन? फिर से मैं बता रहा हूं, एक सेगमेंट है एक्स वाई. ओके, उसका मिड पॉइंट है जेड. ओके, xy is a segment and midpoint is z. So I can always write xz is half xy and yz is half xy. मतलब ये जो हाफ आता है ना, जब भी मिड पॉइंट रहेगा तो हाफ आ जाता है, जब भी मिड पॉइंट रहेगा तो हाफ आ जाता है. Are you getting me? You can get half. So now let's see here, children, why did I teach you this? Okay, just have a look at this. Here, even though I had to do a construction, children, I cannot show you a construction by my, please have a look here. I cannot show you my construction by dotted line. So I'm going to, got it? I'm going to show different colors, okay? I'm going to use different color. Just have a look here. I want this BC is half AC. ये BC मुझे क्या दिखाना है? हाफ AC दिखाना है. BC क्या दिखाना है? हाफ AC. अरे BC को कैसा करूं बेटा? प्लीज हियर, ये हाफ कैसा आ सकता है? So I know one idea. If I extend BC and mark a point D on it, in such a way, I'll mark a point D on it in such a way that B is a midpoint of CD. I extend BC. Yeah, extend CB, mark a point D on it, such that B is a midpoint of CD. अरे ये क्यों किया? अरे एटलीस्ट हम बोल सकते हैं BC is half CD. जब भी मिड पॉइंट रहेगा तो हम हाफ ला सकते हैं ना, BC is half CD. लेकिन मुझे तो B से हाफ AC प्रूव करना है, तो ये CD और AC को बाद में इक्वल दिखा देंगे. लेकिन CD और AC को इक्वल तब दिखा पाएंगे when I join this AC or AD also. Got it? So that I can see one big triangle ADC. Got it? In that I can try to show AC and AC and CD equal. So now let's see here once again, children, what I taught you. Okay, try to understand. Okay, I extend BC. This is my construction. See what construction I do. I extend BC. Extend segment BC and mark a point D on it such that B is midpoint of segment CD. Okay, I extend BC, mark a point D on it such that B is midpoint of CD and draw segment AD. Draw segment AD. ऐसा क्यों किया बेटा? कंस्ट्रक्शन ऐसे क्यों किया? अरे जब मिड पॉइंट रहता है तो हम बता सकते हैं BC is half CD. No doubt, BC is half EC I want. Okay, but at least I can say BC is half CD. Okay, so now look here, children, what am I going to do? Look here. Yeah, now you can say BC is half CD. I just call it like this. BC is half CD. Direct. Okay, I call it as 1. And I call this B is midpoint of CD. B is midpoint of CD. Can you see here, children? But I don't want, please, I don't want CD is my answer. मुझे AC मांगता है. तो CD और AC को कैसे इक्वल दिखाऊं? CD और AC को अगर एक ट्रायंगल ADC इक्विलैटरल ट्रायंगल बन जाएगा तो CD और AC इक्वल बोल सकता हूं, साइड्स ऑफ इक्विलैटरल ट्रायंगल. लेकिन इक्विलैटरल ट्रायंगल दिखाने का तरीका क्या है? हाँ, अगर कोई भी ट्रायंगल में अगर दो एंगल 60 हो गए तो मैं वो ट्रायंगल को इक्विलैटरल, तीसरा एंगल भी 60 हो जाएगा बेटा, तो ट्रायंगल को इक्विलैटरल बोल सकता हूं. तो ऑलरेडी इधर देखो, बड़ा ट्रायंगल एडीसी इक्विलैटरल दिखाना है. क्यों इक्विलैटरल ट्रायंगल दिखाना है? ताकि सीडी और एसी इक्वल हो जाए. बड़े सीडी और एसी इक्वल हो जाए तो सीडी की जगह में बीसी हाफ, सीडी की जगह में एसी लिख सकता हूं. लेकिन इक्विलैटरल दिखाने के लिए दो एंगल 60 मांगता है. तो ये बड़ा ट्रायंगल एडीसी में ऑलरेडी एंगल सी 60 है. तो आप देखिएगा, कैन यू शो एंगल डी 60? यस, वेरी इजीली आई कैन शो एंगल डी 60. हाउ I can prove both these triangles congruent. You just have a look. ये दोनों ट्रायंगल को आराम से मैं प्रूव कर सकता हूँ congruent. In triangle ABC and triangle ABD. Can you see these two triangles? Got it? Segment AB, congruent segment AB. What's the reason, children? Common side. Segment AB, congruent segment AB, common side. Common side हो गया. Angle ABC congruent angle ABD. Why? I can say each is 90 degree. Each is 90 degree, children. बाद में segment BC congruent segment BD. Why, children? This is because of construction. B is midpoint by construction. Okay, B is midpoint. We are done. Sure. Therefore, both this triangle ABC, congruent triangle ABD by SAS test. By SAS test. ये दोनों ट्रायंगल्स कॉन्ग्रुएंट हो गए क्या? दोनों ट्रायंगल्स फिट हो रहे. ABC और ABD एक के ऊपर एक फिट होगा. तो एंगल C के ऊपर कौन सा एंगल फिट होगा? Therefore, angle C congruent angle D. Can I say statement number to CACT? But angle C is 60 degree. Okay, statement number 3 given है. Therefore, angle D आपका 60 बोल सकते हैं. Statement number 4 from 2 and 3. From 2 and 3. Now look here, children. I want people to think here. ना ये बड़ा ट्रायंगल को देखो. ये बड़ा ट्रायंगल में नाउ द बिगेस्ट ट्रायंगल इज एडीसी. कैन आई से एंगल सी इक्वल एंगल डी? दोनों 60 दो बार लिख चुका हूं. फ्रॉम 2 and 4. नीचे देखो, सी 60 है, डी भी 60 है. फ्रॉम 2 and 4 आई कैन से. अरे जब कोई बड़ा ट्रायंगल में दो एंगल 60 होता है तो तीसरा एंगल भी कितना हो जाएगा? एंगल सी ए डी भी 60 हो जाएगा बेटा. Remaining angle of a triangle. Remaining angle of a triangle. अगर remaining angle of a triangle. Now listen, ये triangle ADC में तीनों एंगल 60 है. तो triangle ADC is an equilateral triangle. Triangle ADC is an equilateral triangle. And now, got it? Since all its angles are 60 degrees. Now look here, children. So it's an equilateral triangle. Can I say, children, therefore your CD, which you wanted, you didn't want CD in your statement number 1. Therefore, CD equal AC. Can I say statement number 5, sides of equilateral triangle? Sides of equilateral triangle. Sides of equilateral triangle in. Now can I change? Can I come to this BC equal? Okay. Can I say half AC? ये बी सी डी को चेंज कर सकते, सी डी इक्वल टू ए सी हो गया, ये सी डी इक्वल टू ए सी हो गया, ये जो सी डी है इधर, ये सी डी है, वो सी डी किसका इक्वल हो गया बेटा, आप देख सकते हो ए सी का इक्वल हो गया. तो कैन आई रीराइट बी सी इक्वल हाफ ए सी from 1 and 5. So don't you agree? You got your proof, children. Okay, you understood this. Now I want to show the second part. This was the first part. Okay, now the second part, I want to show the side opposite to 60. AB is root 3 upon 2 times AC. So both easier. See what I do, I use Pythagoras theorem in triangle ABC. Listen, I use, this is statement number 6. What you got? Now, in triangle ABC, angle ABC is 90 degree given to you. Okay. So can I use Pythagoras theorem, children? Therefore, AC square equal AB square plus BC square by Pythagoras theorem. Statement number 7 by Pythagoras theorem. Now, why did I think about Pythagoras theorem? Better please have a look here. एक तो रूट मांगता है, रूट 3 अपॉन 2. ये रूट कभी आता है जब स्क्वायर्स रहेगा, स्क्वायर रूट लेंगे तो रूट आ सकता है. तो ये सब स्क्वायर्स में रहेगा, पाइथागोरस थ्योरम में सब स्क्वायर्स में रहता है. नाउ यू सी, यू वांट खाली ए बी और ए सी, आपको खाली ए बी और ए सी मांगता है. ओके, आपको बी सी नहीं मांगता है. ये बी सी के बारे में क्या मालूम है, हाफ ए सी. तो कैन आई से ए सी स्क्वायर इक्वल ए बी स्क्वायर प्लस ये भी हाफ ए सी द होल स्क्वायर हो गया फ्रॉम 6 and 7. अभी देखो आपको सब ए बी और ए सी है, तो आप सिंप्लीफाई करो. ए सी स्क्वायर इक्वल ए बी स्क्वायर प्लस 1 अपॉन 4 ए सी स्क्वायर. 1 अपॉन 4 ए सी स्क्वायर ए साइड आया, ए सी स्क्वायर माइनस 1 अपॉन 4 ए सी स्क्वायर इज इक्वल टू ए बी स्क्वायर. Now this is LCM is 4. So 4AC square minus AC square is upon the whole thing upon 4 is equal to AB square. तो अभी सिंप्लीफाई करो. सिंप्लीफाई कैसे करेंगे बेटा, कोई भी समझ सकता है. इधर मैं करके दिखा रहा हूँ, प्लीज आप लोग के जगह नहीं है, मेरे को इधर लिख रहा हूँ अभी. Please pay attention here, try to understand this. Okay, so what will happen, 3AC square upon 4 is equal to AB square. Come on, take square root. So taking square root, root 3, 4 ka square root 2, AC square ka AC, AB. So don't you agree, you got your answer. AB equal root 3 upon 2 AC. Children, 30, 60, 90 theorem, this theorem you learned it in your 9th standard. I don't know whether it will be asked in your 10th standard, but just I showed it to you. Okay. Now, we go to the next theorem, children. Let's start with the new theorem, children, 45, 45, 90 theorem. Again, a theorem which you learned in your 9th standard. Okay? The measures of the angles of a triangle are 45 degree, 45 degree, and 90 degree. Then, length of each of the perpendicular sides is 1 upon root 2 times the hypotenuse. What does it mean? If के बाद जो है, if you see this condition, the condition which follows it, if you see this condition, you should apply the condition which follows then. That is what the theorem says, okay? Like if the measure of the angles of a triangle are 45 degree, 45 degree, and 90 degree. Like you see a triangle, okay? Where the angles are 45 degree, 45 degree, and 90 degree, okay? Like you see one 90 degree angle, you see this angle is 45, you see this angle is also 45. So such a triangle is called a 45, 45, 90 triangle. Then length of each of the perpendicular sides. If you see this 45, 45, 90 triangle, you know, length of each of the perpendicular, the sides which make 90 degree angle AB and BC, उनको बोलते हैं perpendicular sides. Sides जो 90 degree angle बनाते हैं उनको बोलते हैं perpendicular side. Length of each of the perpendicular side मतलब AB equal 1 upon root 2 AC, and even this BC equal 1 upon root 2 AC. ये फॉर्मूला को बोलते हैं 45 45 90 थ्योरम. ये फॉर्मूला खाली 45 45 90 ट्रायंगल में यूज कर सकते हैं. इसके लिए इसका नाम है 45 45 90 theorem. Okay, now if it comes in your exam, for prove that. Okay, if it comes in an exam to if it comes in an exam like this, prove that if the measures of the angles of a triangle are 45 degree, 45 degree, and 90 degree, and then length of each of the perpendicular side is 1 upon root 2 times the hypotenuse. If it comes in an exam like this, prove that if the measures of the angles of a triangle are 45 degree, 45 degree, and 90 degree, then length of each of the perpendicular sides is 1 upon root 2 times the hypotenuse. So remember, children, if के बाद जो है given है, that means I should be able to draw a diagram according to it. Yes, I can draw it, measure the angles of a triangular 45 degree, 45 degree, and 90 degree. Okay, I draw this triangle. Okay, measure of the angles of a triangular 45 degree, 45 degree, and 90 degree. Okay, I have drawn it. Now look here, children, this is angle ABC. Okay, this is 45. This is 90, so third angle has to be 45. Okay, so given. Okay, in triangle ABC, what I drawn, I should write it as given. This picture talk in triangle ABC, क्या है? Angle B equal 90 degree है, और बाकी दोनों angle A equal angle C equal 45 degree है. So what do you want to prove that? Prove that okay, length of each of the perpendicular sides is 1 upon root 2 times the hypotenuse. This AB equal BC, length of each of this perpendicular side is 1 upon root 2 AC. Now children, people should understand ये root sign कभी आता है जब ये x square रहेगा, x square equal 3 आ गया तो x equal root 3 आता है. x square equal 5 आता है, x equal root 5 आता है. मतलब स्क्वायर रहेगा, स्क्वायर रूट लेने से रूट आ सकता है. तो ये जस्ट ट्राई टू अंडरस्टैंड, आपको ये प्रूफ में रूट 2 आना है, रूट 2. लेकिन ये रूट 2 कभी आएगा जब स्क्वायर से रहेगा. तो ज्योमेट्री में ऐसा कौन सा थ्योरम है जिसमें स्क्वायर आएगा? पाइथागोरस थ्योरम. सो आई हैव टू यूज पाइथागोरस थ्योरम. देखो, इन ट्रायंगल एबीसी, ओके, angle ABC equal 90 degrees. Angle ABC equal 90 degrees. So what will be Pythagoras theorem? Angle ABC equal 90 degrees, children. So what will be Pythagoras theorem given? So Pythagoras theorem will be, therefore, AC square equal AB square plus BC square. I call this as 1 and Pythagoras theorem by Pythagoras theorem. Okay, but then आपको प्लीज आप लोग क्या देखो, ये गिवन क्या है फिगर में? अरे एंगल A इक्वल एंगल C गिवन है, each is 45. But remember, in geometry, when two angles of a triangle are equal, the sides opposite to them are equal. तो A का opposite side BC होता है और C का opposite side AB होता है. Therefore, BC equal AB. I call this as 2 by converse of isosceles triangle theorem. By converse of isosceles triangle theorem. Isosceles triangle theorem. Now you can just have a look here. AC square equal AB square by BC square, but if BC and AB are equal, so can I change this BC? Can I change this BC to AB? So what will happen? AC square equal, therefore AB square plus AB square. Can I say from 1 and 2? From 1 and 2. So what happens here? AC square equal to AB square. But you want AB square alone. So A, not 2, I want AB square alone. So the 2 comes down. 1 upon 2 AC square equal AB square. Now you can take square root, children, And when you take square root on both sides, what you get? Therefore, 1 upon root 2 AC. Square root of AC square is AC. Square root of AB square is AB. So you got your answer. Therefore, AB equal 1 upon root 2 AC. And also, can I say BC equal? So BC equal AB or no? BC equal, therefore, also BC equal 1 upon root 2 AC. Can I say from 2 children? Because 2 में देखो BC है AB and BC equal AB है. Okay, so this is 45, 45, 90 theorem. Again, a theorem not so important, I feel, but it was taught to you in your 9th standard. Okay, we go ahead, children. Application of theorem of Pythagoras for acute angle. Children, this is one formula. The name of the formula, we call it as application of theorem of Pythagoras for acute angle. This formula, ये formula जो है, आप खाली एक acute angle triangle में use कर सकते हैं. This triangle ABC is an acute angle triangle. And a height should be given in the triangle, AD perpendicular BC. So remember, when to use this formula, the triangle should be an acute angle triangle and the height on that in that triangle should be given. फिर से कभी फॉर्मूला यूज कर सकते हैं जब वो ट्रायंगल के एक्यूट एंगल ट्रायंगल है और एक हाइट ड्रॉ किया गया है. Now look at any one acute angle. Suppose I start with this acute angle B. तो उसका opposite side है red side है ना. What the formula says, the square of the side opposite to this red side, that is AC square. Square of the red side. Side opposite to that acute angle. I consider angle B as an acute angle. And you can see a altitude is drawn in front of it. Okay. So this square of the side opposite to this acute angle is equal to sum of the squares of the sides containing the acute angle. Like angle B is acute angle I'm talking about. Which sides are containing it? The green sides which are done, they are containing it. So naturally AB square plus BC square. Square of the side opposite acute angle equal sum of the squares of the sides containing acute angle. Containing acute angle. Which sides are containing acute angle? AB and BC. So AB square plus BC square. Minus, since it's an acute angle, minus sign will come in the formula. Minus, okay? Twice, 2 times, okay? Now look here. Suppose AC square लाने के लिए कौन सा right angle triangle लेते थे Pythagoras theorem use करके AC square ADC. तो उसका बेस कौन सा है बेटा? DC. फिर DC को आप स्प्लिट कैसे करेंगे? DC को you can split DC as BC minus BD. Am I right? You can split DC as BC minus BD. फिर से मैं बोल रहा हूँ AC square लाने के लिए कौन सा right angle triangle लेते थे? Triangle ADC. Am I right? Pythagoras theorem use करके AC square लाने के लिए triangle ADC. उसका बेस कौन सा है? DC. ये DC को किस तरह से स्प्लिट कर सकता हूँ? BC minus BD. माइनस साइन आ रहा है ना, इसके लिए माइनस 2 and product of these segments which are involved in the splitting of DC to BCBD. Are you getting me, children? So remember this formula. Square of the side opposite to acute angle. This right side, okay, is the side opposite to acute angle, AC square, equal sum of the squares of the sides containing the acute angle. These green sides are containing the acute angle B. So AB square plus BC square. Minus sign comes. You know why minus sign comes? I'll tell you. Okay, 2 into product term. Now, what is this? Product of which segments? You can see here. Okay. I told you AC square लाने के लिए कौन सा right angle triangle आप लेंगे? ADC. Pythagoras theorem use करेंगे तो AC square मिलेगा. उसका बेस कौन सा है? DC है. ये DC बेस को split कैसे करूंगा? DC को BC minus BD. So twice the product of the segments which are involved in the splitting of DC, BC and BD. Are you getting me here? Got it? So remember this, children. They'll ask you to prove this only. So it is like, please keep in your mind, it can be asked like this. Got it? Suppose in triangle ABC, it will just come in the form of a question, okay? It will come in the form of a question like this exam may. Got it? In triangle ABC, okay? They'll say angle ABC is less than 90, but like acute angle hai. Got it? Segment AD perpendicular. Segment AD perpendicular segment BC. This is also given. And they will ask you to prove that this formula, square of the side opposite to acute angle AC square equals sum of the squares of the sides containing the acute angle AB square plus BC square minus This twice the product of the segments. This segments, how to get it, I showed you, okay? Like DC is a, like AC square is the side of which right angle triangle ADC. उसका base कौन सा है? DC. DC को split कैसा करूंगा? BC minus BD. So minus sign इसके लिए twice BC BD. Now the proof of it is so simple, children. Please have a look. I'm sure everybody can understand it very easily. Very easy, children. Suppose you think like this segment which is there on the left hand side, AC square, कैसे लाएंगे AC square? AC square से start करना है. मुझे AC square मांगता है. मुझे AC square मांगता है. Okay? How to get AC square? Okay? Here, children, how to get AC square? How to get this AC square? So naturally, I'll have to take this triangle ADC. In this triangle ADC, I'll have to show angle ADC equal 90 degrees. So naturally, angle ADC is 90 degree, but it's a right angle triangle. So I can use Pythagoras theorem. So what is Pythagoras theorem? AC square equal AD square plus CD square by, I call this as statement number 1 by Pythagoras theorem. Now you can see, children, your AC square is come. But the other things what you want in your answer, you have not got it. You have not got it. So how do you go about? Listen, AC square you got it. AD square is also okay. And CD square is there. तो अभी इसको आगे कैसा बढ़ो? AC square I got it. So इधर CD को अभी कुछ कर सकते हैं. CD को I can split it as BC minus BD. So what I do? AC square equal AD square as it is. CD को कर सकते हैं BC minus BD. What it is? CD is what? BC minus BD the whole square. Because you can see, children, B dash, D dash, C. Okay. Now what will happen? AC square as it is, AD square plus A minus B the whole square is what? A square minus 2AB, 2BC, BD plus BD square. Okay. Now you can see, children, when you compare to the answer, you want AC square in your answer, you want BC square in your answer, you want minus 2 BC BD in your answer, you don't want AD square and BD square. Just look at AD square and BD square. Array, what happens? Suppose I call this as statement number 2. Now you don't want AD square and BD square. So look at this triangle ADB, children. In triangle ADB, angle ADB equal 90 degree given or not? So naturally, what will be Pythagoras theorem here? You can see here, children, your AD square, AB square equal AD square plus BD square, hypotenuse square equal one side square plus other side square, Pythagoras theorem. Okay, by Pythagoras theorem. And now you can see, children, Pythagoras theorem. Okay, what will happen, children? This AD square in place of this AD square and BD square. I don't want this AD square and BD square. What is AD square plus BD square equal to AB square? So can I replace? I'm rewriting this statement number 2. AC square equal AD square or BD square का जगह में what is AD square and BD square equal to AB square plus BC square minus 2BC BD. I think I got my formula. Okay, what I wanted from 2 and 3. Sure, children. This is application of theorem of Pythagoras for acute angle. Got it? Same way, you're going to learn application of theorem of Pythagoras for obtuse. Now you can see, children, we're going to learn the second one, application of theorem of Pythagoras for obtuse angle. Like in this triangle ABC, angle ABC is greater than 90 degrees. It's an obtuse angle. And you see a height has been drawn. Got it? On the base of this obtuse angle triangle. Can you see here? AD perpendicular BC. When you see this condition, obtuse angle and a height has been drawn. Remember one very important theorem. The square of the side opposite to obtuse angle. Square of the side opposite to obtuse angle is equal to, this is the square of the side opposite to obtuse angle. You can see this side AC is a side opposite to obtuse angle. Square of the side opposite to obtuse angle, okay, is equal to sum of the squares of the sides containing the obtuse angle. Now you can see here, Which sides are containing the obtuse angle? Which sides are containing the obtuse angle? One is side BC. Okay, can you see this BC? BC is containing the obtuse angle. Okay, and the other one is AB. AB is containing the obtuse angle. So see, the theorem says like this, the formula says like this: square of the side opposite obtuse angle, square of the side opposite to obtuse angle. Which side is opposite to obtuse angle, children? You can see here, which side is opposite to obtuse angle? AC square. So square of the side opposite to AC square equal square of the side opposite obtuse angle equals sum of the squares of the sides containing the obtuse angle. Which sides are containing the obtuse angle? AB and BC. So AB square plus BC square. Are you getting me here? Got it? Just like Pythagoras theorem, square of the side opposite to right angle is sum of the squares of the two sides containing the right angle. Just like that, AC square equal AB square plus BC square. लेकिन 90-degree angle लेकर कुछ extra आएगा इधर. Plus, listen here. Plus, okay, twice the product of the segment. Which segments I'll tell you. जैसे AC square लाने के लिए कौन सा right angle triangle लेंगे? ADC. तो ADC में AC square लाने के लिए ADC right angle triangle लेंगे, which is a base. DC is a base. So अभी DC को split कैसे करेंगे? BC plus BD. तो स्प्लिट कैसा होता है? BC plus BD. तो ये प्लस साइन के साथ होता है. DC बड़ा सेगमेंट है करके प्लस. So 2 into BC into BD. 2 into BC into BD. This will come in the formula. Are you getting me up? There's a way to remember. Square of the side opposite obtuse angle is equal to sum of the squares of the sides containing the obtuse angle plus 2 into product of the segments. That segments, how to take, I showed you, children. So suppose the proof of it comes in an exam. Like it will come like this, given in triangle ABC, in triangle ABC, angle ABC is greater than 90-degree obtuse angle, and segment AD is perpendicular to line BC. Segment AD is perpendicular to line BC. And what did you prove that? Prove that AC square equal, here on top you're written already, okay? You have to prove this, children. Prove this. Prove what is that? Prove that AC square equal AB square plus BC square plus this product of the segment. Okay, the segment I told you how to get that segment. AC is the side of right angle triangle ADC. AC square लाने के लिए right angle triangle ADC लेंगे. तो उसका बेस कौन सा है? DC. उसको स्प्लिट कैसे करेंगे? BC plus BD. तो ये जो segments involve होते हैं ना splitting में, उनका twice the product of the segments. Got it? तो अभी इसका प्रूफ देखो कितना easy है. ये फॉर्मूला समझ गया? चलो पहला AC स्क्वायर लाएंगे. कैसे लाएंगे? In triangle ADC, okay? In triangle ADC, angle ADC equal 90 degrees given to us. So what will be Pythagoras theorem? AC square equal AD square plus CD square by statement number 1 by Pythagoras theorem. By Pythagoras theorem. Now you can see your children, what will happen, which is the base of it. CD is a base. So what will happen? AC square equal, okay, AD square. You can see this base CD, how it is split in BC plus BD, the whole square. CD is splitted as, please have a look at C dash, B dash, D. It got splitted like this. Now, you know, children, you know the formula. AD square. What is this formula? A plus B the whole square is A square plus 2AB plus B square. So BC square plus 2BCBD plus BD square. Okay. Now you can see here, children, what AB square, AC square you want in your answer. You want BC square in your answer. You want 2BCBD. But you don't want AD square in your answer. You don't want BD square in your answer. Look, AD square and BD square नहीं मांगता आंसर में. लेकिन AD square और BD square को ध्यान से देखो. It's the sides of right angle triangle ABD. AD square plus BD square is nothing but AB square. So I'll have to show that. Okay, I call this as 2. Now, in triangle ADB, what is this, children? Angle ADB equal 90 degrees given. So what will be Pythagoras theorem here, children? Therefore, AB square equal AD square. Your AD square plus BD square. BD square. You can see here, children, statement number 3 by Pythagoras theorem. By Pythagoras theorem. Now what happens, children? You can see AC square, as it is AC square, you're rewriting your statement number 2 with the help of 3. AC square, as it is the AD square plus BD square. What is AD square plus BD square? AB square. I'll write AB square plus BC square plus 2BC Got it? 2BC Sure, children. The reason is from 2 and 3. Okay. So this is application of theorem of Pythagoras. So now, till today, Apollonius theorem has never come in the exam. All these sums have come once or the other, okay? But Apollonius theorem कभी आया नहीं है. Got it? 40 साल में तो मेरे सामने Apollonius theorem कभी आया नहीं है, okay? So I feel, children, we will not do that, okay? It's not hard. It's just a combination of theorem of Pythagoras for acute application of theorem of Pythagoras of acute angle, application of theorem of Pythagoras for obtuse, दोनों को add करके आपको Apollonius theorem का proof आ जाएगा, okay? But anyhow, it should not come. So anyhow, that's all for all the theorems of the second chapter. That is what I feel. I've given it here, okay? Text, okay, children.